Alright, so let's continue on with mini-grep. And I believe the next part is reading a file. Now we'll add functionality to read the file that is specified in the file name command line argument. First, we need a sample file to test it with. The best kind of file to use to make sure mini-grep is working is one with a small amount of text over multiple lines with some repeated words. Listing 12-3 has an Emily Dickinson poem that will work well. Create a file called poem.txt at the root level of your project and enter the poem, I'm Nobody, Who Are You? Great poem, by the way. Let me do that now. I can move this to the left, open my editor. There we go. Have the sidebar. In main, I'll just create another file. And they want me to call it poem.txt. Poem.txt. Cancel, and then for the poem, let me move this. This doesn't have to be that large. Yeah, I'm not going to type this out, I just copy it. Control. With the text in place, edit source/main.rs and add code to read the file as shown in listing 12-4. Alright, see they have source code there. Make this bigger. I'm guessing this starts from the end of here. Print in file, which is this line, line 10. So the next part is let contents equal fs, which is I guess file system, read. Oh, we haven't imported file system yet. So we have use standard library file system. Now file system read to string file name, and then we want to print out the context. Oh wait, before we do that, we want to do a expect just in case there's an error. Something went wrong. Okay, something went wrong. Something went wrong reading the file. And last, we want to print the file contents. Line contents. And we want to see if this works. Alright, so we added that line. We can get rid of view, and we just need the terminal. So one thing to note is I didn't put it at the root of my directory. I put the poem.txt in the source file. My bad, but I can just move it. Let's just move it so it's compatible with everything that's in the document. So we're going to move source poem to here. And now we can see the poem.txt is here. So now we can do things like cargo run. The query is going to be the and poem.txt. We're not searching for anything yet, but we can see the output's already here. Searching for the in file poem.txt with text is what we just added right here. And here's the content of the poem. I am nobody, who are you? Going all the way down to the last name, or the last line. Close that. Alright, see what else they want us to do. First, we add another use statement to bring in a relevant part of the standard library. We need standard library fs to handle the files, which is this line right here. In main, we've added a new statement, file system read to string, takes the file name, opens that file, and returns a result string of the file's contents. And that is done right here. And the reason why you know it's a result string is because we use an expect, and if there was an error, we will see this line. Otherwise, if it's okay, we just get the contents. After that statement, we've again added a temporary print line statement that prints the value of contents after the file is read. So we can check that the program is working so far. And we saw that was right here, and we got to see the output. Let's run this code with any string as the first command line argument, because we haven't implemented the searching part yet, and the poem.txt file as the second argument. And we did what they have here. We have the and the poem, which we ran, and this is the output. Great! The code read and then printed the contents of the file. But the code has a few flaws. The main function has multiple responsibilities. Generally, functions are clearer and easier to maintain if each function is responsible for only one idea. The other problem is that we're not handling errors as well as we could. The program is still small, so these flaws aren't a big problem, but as the program grows, it will be harder to fix them cleanly. It's a good practice to begin refactoring early on when developing a program because it's much easier to refactor smaller amounts of code. We'll do that next. So in the next section, we're going to be refactoring code. Let's do it. But to go over what they were saying here, some issues is that our main function has multiple responsibilities. We see here it's responsible for setting up the, let's say, config with the arguments in the query, and it's responsible for reading the contents of the file, and it's responsible here for printing, even though this is just like a temporary stub. But you can see this is multiple things already, which can be broken out into different functions themselves. And then the error handling, which they mentioned, was this: we just have an expect here, but outside of that, we talked about earlier, the arguments, if they don't exist, we just get a batch race, a panic, something that happens at runtime. That's not good either. So things like that should be fixed, and hopefully it'll be fixed in the next section. Moving onward, there's a lot of text here, so let me expand this. Refactoring to improve modularity and error handling. To improve our program, we'll fix 4 problems that have to do with the program structure and how it's handling potential errors. First, our main function now performs 2 tasks. It parses arguments and reads files. For such a small function, this isn't a major problem. However, if we continue to grow our program inside main, the number of separate tasks the main function handles will increase. As a function gains responsibilities, it becomes more difficult to reason about, harder to test, and harder to change without breaking one of its parts. It's best to separate functionality so each function is responsible for one task. So in this paragraph, they mention at the very least that our main function has 2 responsibilities right now. 1, it parses arguments. 2, it reads files. These things are things that can be broken up into their own functions. The reason why you should break them up into their own functions is because then it's easier to reason about, because somebody can look at that one function, know that one function does this one task, and you can test that one task and make sure it does it well. And then you don't have to worry about main doing everything, because if main does everything, it's going to be confusing to explain to other people, and possibly yourself, what is main actually doing. This issue also ties into the second problem. Although query and file name are configuration variables to our program, variables like content are used to perform the program's logic. The longer main becomes, the more variables we'll need to bring into scope. The more variables we'll have in scope, the harder it is to keep track of the purpose of each. It's best to group the configuration variables into one structure to make their purpose clear. Ooh. This was a good paragraph. So one of the issues they mentioned is that our variables, which are kind of confusing right now, we have query and file name, which are more configuration. They're configuration because we're passing them into our program and they are needed explicitly as parameters for what our program is going to act on. So then we have other variables like contents, which are used to perform programming logic because we're acting on the contents. We're going to be searching through them. That's very different from configuration. And in this paragraph, they also mention how they want to separate it to make things clearer. So we're going to put configuration into a configuration structure. The third problem is that we've used expect to print an error message when reading the file fails, but the error message just prints something went wrong reading the file. Reading a file can fail in a number of ways. For example, the file could be missing, or we might not have permissions to open it. Right now, regardless of the situation, we'd print the something went wrong reading the file error message, which wouldn't give the user any information. Quick summary, they're saying our error handling currently sucks and it needs to change because the message that we give tells us nothing about the actual situation and does not help the user or the programmer figure out what's going on or what went wrong. Fourth, we used expect repeatedly to handle different errors. And if the user runs our program without specifying enough arguments, they'll get an index out of bounds error from Rust that doesn't clearly explain the problem. It would be best if all the error handling code were in one place so future maintainers had only one place to consult in the code if the error handling logic needed to change. Having all the error handling code in one place will also ensure that we're printing messages that will be meaningful to our end users. Let's address these 4 problems by refactoring our project. That one was pretty harsh. So the fourth one was they just wanted to talk about error handling, and they want to consolidate all the error handling into one place. So it's clear for at least the programmers and maintainers where they have to go to manipulate and change how error handling works. And the example they brought up was, yes, we're using expect, but index out of bounds. So we said earlier that at our arguments, if a user does not provide enough arguments, then one of these is going to be missing, one or both. And then we're going to try to search for them in this vector and not find them, which is going to give us an index out of bounds error, which is not helpful to the user at all. That has to be fixed. Next section. Separation of concerns for binary projects. Make it bigger for now. The organizational problem of allocating responsibility for multiple tasks to the main function is common to many binary projects. As a result, the Rust community has developed a process to use as a guideline for splitting the separate concerns of a binary project when main starts getting large. The first process has the following steps. So it looks like organizationally, at least for binary project, there's already a guideline that people follow in the Rust community. And these are the steps. First step, step 1. Split your program into main.rs and a lib.rs and move your program's logic to lib.rs. Okay, that makes sense. So what they're saying in the first step is that your logic should not exist in main.rs, it should exist in libs.rs, which I guess separates the concern. You can test a library and then you could export a library, but your main function shouldn't really have too much logic in it. Okay? Step number 2. As long as your command line parsing logic is small, it can remain in main.rs. I guess that counts as a guideline. They're saying your command line logic, as long as it's very tiny, it can stay there, but if it gets larger, then you should move it to libs.rs and properly test it with everything else. Step 3. When the command line parsing logic starts getting complicated, extract it from main.rs and move it to libs.rs. Which I just stated. It's really 2 guidelines, but okay. That third one, it's a different sentence. Meh. The responsibilities that remain in the main function after this process should be limited to the following. Okay, what should main do? The things that main should do are the following. Calling the command line parsing logic with the argument values, setting up any other configuration, calling a run function in lib.rs, handling the error if run returns an error. Okay, that makes sense. So basically what they're saying is main is responsible for calling your logic, and your logic should exist in lib.rs. Main is also responsible for handling any errors that pop up, and any other configurations that are needed, and at times calling the parsing logic. But outside of those 4 things, main shouldn't do anything else. Your program, like the core of your program, should exist in the lib directory, lib file. This pattern is about separating concerns. Main.rs handles running the program, and lib.rs handles all of the logic of the task at hand. Because you can't test the main function directly, this structure lets you test all of your program's logic by moving it into functions in lib.rs. The only code that remains in main.rs will be small enough to verify its correctness by reading it. Let's rework our program by following this process. Alright. So here they're just saying what I was saying earlier. The stuff in lib.rs is things that you can test. If you want to be able to test your program, you need to be able to separate it in such a way that is out of main, because you cannot test main. So the only thing that exists in main are things that you can easily verify, which is the running of the code and possibly handling errors. Anything outside of that, go to lib.rs, test it properly. Extracting the argument parser. Let's get it. We'll extract the functionality for parsing arguments into a function that main will call to prepare for moving the command line parsing logic to source.lib.rs. Listing 12-5 shows the new start of main that calls a new function, parseConfig, which we'll define in source main.rs for the moment. And let's see what they have here. ParseConfig, which they'll leave it here for now, but we're going to move it later. ParseConfig, and it takes arguments, args, a pointer to a vector of strings, and it returns 2 small strings. And then we have let query. We're just moving the logic out. Equal args 1. That looked about right. Let file name equal args 2, and then we're returning the tuple query and file name. And then you still have that stuff, but now we're calling parse args. What do they call it? Right here. So this gets changed. And I was unaware that you can define or declare 2 variables at once. But that's kind of cool. It's good to know. Query and file name equal parseConfig. And we're passing in the args. Since that's a small change, that should work, but let's find out. And it does work. Cool. I was kind of concerned because these have a question mark after them, which is alarming, but I just ran it. It works. Moving onward. We're still collecting the command line arguments into a vector, but instead of assigning the argument values at index 1 to the variable query, and the argument value of index 2 to the variable file name within the main function, we pass the whole vector to the parseConfig function. The parseConfig function then holds the logic that determines which argument goes in which variable and passes the values back to main. We still create the query and file name variables in main, but main no longer has the responsibility of determining how the command line arguments and variables correspond. So yeah, that paragraph just covered the separation of concerns. So before, this stuff was all in main. However, now that we moved it out of main, if there are any other logic that we need to add, we can do it here for the most part. This is a really small program, so it's kind of hard to see the efficiency in it, but if this was a larger program and we had a ton of different arguments, putting that stuff here and taking it out of main would make main so much smaller. Like if this was like 50 lines, that would be great. Not great in terms of like memory management and figuring it out, but taking like a big chunk out of main and putting it someplace else, so then your main function looks nice and tight and you can easily read and follow the logic. That's good. This rework may seem like overkill for our small program, but we're refactoring in small incremental steps. After making this change, run the program again to verify that the argument parsing still works. It's good to check your program often to help identify the cause of problems when they occur. Yeah, we just said all of that. It does seem like overkill for this small project. I agreed, and we did run it to make sure it still worked. Cool. Moving onward. Grouping configuration values. We can take another small step to improve the parse config function further. At the moment, we're returning a tuple, but then we immediately break that tuple into individual parts again. This is a sign that perhaps we don't have the right abstraction yet. This is very telling. So what they're saying in that section, that paragraph, is that in the parse config function, right, we're returning a tuple, but immediately after we return the tuple, we break up the tuple, which is sort of awkward. If we needed to break it up, why did we return the tuple in the first place? This is a question that we should probably be asking ourselves as the developer. And what they're saying here is that this is a sign that perhaps we didn't use the right abstraction yet. So we should probably change this. Let's see what happens. Another indicator that shows there's room for improvement is the config part of parse config, which implies that the two values we return are related and are both part of one configuration value. We're not currently conveying this meaning in the structure of the data other than by grouping the two values into a tuple. We could put the two values into one struct and give each of the struct fields a meaningful name. Doing so will make it easier for future maintainers of this code to understand how the different values relate to each other and what their purpose is. That was a mouthful. So what they're saying here is that parse config has the word config in it. Config is short for a configuration. When you have a configuration, that sort of implies that there are parts within this configuration that are all related to each other. Currently, we have a tuple, and then we break the tuple up. If someone was looking at this, there's no real tie to why query and file name need to be together. And because that is pretty ambiguous right now, that's probably a bad thing. In order to convey our meaning in a clearer manner, we're going to put these variables together in such a way that it's clear when you see them on the screen on your editor that they are related. And seemingly we're doing that with a struct. Moving down, yep, here we go, struct config. Note, using primitive values when a complex type would be more appropriate is an anti-pattern known as primitive obsession. I'm not sure if they needed to add this note, but okay, moving onward. Listing 12-6 shows the improvements to the parse config function. And here we go. So we have parse config, and it comes out to a config. And we have our struct config. So let's add that first. Put that up here. Struct config. And we have our query, which is going to be a string. And we have our file name, which is going to be a string. Different types of strings now. So this is on the heap, where this was on the stack. So that's something to note. And then our parse config is now going to return a config struct, or instance of our config struct. So if you notice here, we clone them. Clone, because we now need them to be on the heap. Clone, and we can pass those things into config. And that's yelling at us because we didn't say what we're returning yet. Config. So really quickly, let's go over parse config. Parse config still takes in the string, the array vector of strings that we make into our query and file name. Only thing that changes now that we're returning an instance of config, which couples our query and file name. So anybody looking at this knows that these things are definitely related. And yeah, moving onward. Now we have to change this so it's config. Config. That's what they did here, right? And then we can call everything directly. So config dot query, as they have there. Config dot file name, as they have there. And given that that's the only thing that changes to still work. And I have an error. Found type. I see. So I probably copied something wrong. Hold on, let me see real quick. Args are the same. That's where I made a mistake. These are no longer pointers. And file name's not found. File name I forgot to change, so that's here. It's now config, not file name. Voila. Everything is the same now. Everything is working as it was before. So the error I had was pretty much I forgot to change file name to config.file name. Moving onward. We've added a struct name config defined to have fields name, query, and file name. The signature of parse config now indicates that it returns a config value. In the body of parse config, where we used to return string slices that reference string values in args, we now define config to contain own string values. The arg variable in main is the owner of the argument values and is only letting the parse config function borrow them, which means we violated Rust's borrowing rules if config tried to take ownership of the values in args. That was a mouthful as well. A lot of highlighted words too. Pretty much what they're saying here is that we've created config. Config takes ownership of query string and file name. However, when we pass the args into parse config, we're only borrowing them. In order to fix the borrowing, we have to clone. I say fix, but we're just cloning to make sure that we don't take ownership of the things that were passed in. We could manage the string data in a number of different ways, but the easiest, though somewhat inefficient, route is to call the clone method on the values. This will make a full copy of the data for the config instance to own, which takes more time and memory than storing a reference to the data. However, cloning the data also makes our code very straightforward because we don't have to manage the lifetimes of the references. In this circumstance, giving up a little performance to gain simplicity is a worthwhile trade-off. This paragraph is solely talking about the argument of whether or not we should have cloned the variables or cloned the values that we passed in. So in one respect, we have a clone adds things to the heap, which is taking up more memory. However, if we didn't do that and we just programmed with references, then we have to make sure we program the lifetimes or deal with the lifetimes properly throughout our program. One is a headache, the other one is easy but inefficient. In this program, we're saying that the trade-off for simplicity is well worth the non-headache of dealing with lifetimes. And that's why we chose to clone, to avoid dealing with lifetimes, seemingly. The trade-offs of using clone. There's a tendency among many Rustaceans to avoid using clone to fix ownership problems because of its runtime costs. In Chapter 13, you'll learn how to use more efficient methods in this type of situation. But for now, it's okay to copy a few strings to continue making progress, because you will make these copies only once and your file name and query string are very small. It's better to have a working program that's a bit inefficient than to try to hyper-optimize code on your first pass. As you become more experienced with Rust, it'll be easier to start with the more efficient solution. But for now, it's perfectly acceptable to call clone. So here they brought up a good point. If this is your first time writing a program, and this is you're just going through it, trying to get it to work, you should focus on trying to get it to work, and not focus on optimizing it so that it's the most efficient, fastest, lightweight program there is. Because at that point in time, that's not what's important. On your second and third pass, even fourth pass, you can work on those things. But when you're getting started, try to get your goal accomplished. Try to get that done first. And if that means using clone, by all means, use clone. It's okay. We've updated main so it places the instance of config returned by parse config into a variable name config. And we updated the code that previously used these separate query and file name variables, so it now uses the fields on the config struct instead. Now our code more clearly conveys that query and file name are related, and that their purpose is to configure how the program will work. Any code that uses these values knows to find them in the config instance, in the fields named for their purpose. Here they're just reiterating again what we did in terms of refactoring when we made the config, and they're just talking about how our code is now much clearer in intent. So we have a config, and anybody that looks at this config knows that this configuration is used to throughout our program to tell it how it works, and that config query and config file name are tightly related. Yeah, compartmentalize our code. It's clear in intent. Nothing big.